warahmatullahi wabarakatuh. Today we are going to discuss about the microcontroller and how to use microcontroller for different types of automation. We will be focusing our microcontroller based automation for Arduino based microcontroller or development board. So Arduino is a very common platform, hardware platform to be used for microcontroller based projects. So I have gathered these slides from various sources from internet, particularly from SlideShare, and then I modified, compiled them to for better, for more suitable for the students I am lecturing. So I have to acknowledge these sources, which is I received from SlideShare. But I did carry out some modification and addition of more slides and from different sources to compile them into single presentations. So basically, what is Arduino? Arduino is an open source microcontroller development platform used for building electronics projects. There are various types of Arduino boards available. What is a microcontroller? A microcontroller you can think of as a small, tiny controller which has RAM, ROM, central processing units, CPUs, and all these things. So the most common Arduinos available are Arduino Uno and Arduino Mega. Arduino Uno uses a microcontroller Atmega 328P, and Arduino Mega uses Atmega 32560, and their processing speed is 16 megahertz each. The smaller version of Arduino is Arduino Nano, which has limited number of IOs. Arduino Uno has some, you can say it is in between Arduino Nano and Arduino Mega. So Arduino Mega has more number of IOs, and Arduino Duo is high speed processing power with 84 megahertz clock speed. So it has high performance prototyping it is applicable for high performance prototyping with superior analog IO. So for high frequency measurement, you can use 84 megahertz Arduino Duo DUI. Okay. Now, this is a typical structure of an Arduino Uno microcontroller board. So you have the Atmega chip here, which is the microcontroller chip, and you have the power source, the V in, um, and basically you have the analog pins. These are the analog pins. So it has a built-in analog digital conversion. So you can put in analog sensors here, and so this is the light on turn 5-volt on indication lead LED, and you have in circuit serial programming, which we will see what is serial programming, and this is the serial communication TX transmission line and receiving line, and you have digital IOs, which is for digital switches and digital sensors, and you have analog reference voltage and the ground, and then you have a reset button, and you have the USB interface chip and USB port, and you have a voltage regulator because Arduino runs in 5 voltage, so basically you need to have a voltage regulator as well. Okay, now this is the USB port that is connected to your computer to program the Arduino and to download the program to Arduino microcontroller, EEPROM, and then this is you can use external once you develop the system. If you want to make it standalone running, so you have to power up the system. So you have to give power to the Arduino board through this point, and it is 5-volt, but it can withstand a maximum voltage of 20 volt. So this is the uh, power supply. Now, so microcontroller is the brain of this Uno board is Atmega 328, Atmega 328P. Following component, it has the flash memory of 32 kilobytes, RAM of 2 kilobytes, CPU has a it has a CPU which is AVR RISC architecture, and then you have EEPROM, which is basically 1 kilobyte of memory, which basically holds your program there. You have analog IOs, input out analog pins. Uno has 6 analog input pins, basically 0 to 5. So you can connect any analog sensors to these pins. And then you have digital IOs, which are mostly used. It can be considered as an input and output for digital. You can generate pulses or you can receive pulses through these digital IOs. Reset switch is to reset the system. You can use this reset switch. And this oscillator is a 16 megahertz oscillation. This basically creates the timing inside the microcontroller, generates the timing. So 16 million times a second because 16 megahertz. Um, and then uh, on each tick, the microcontroller performs some operation. TX stands for transmission data, RX stands for receiving data. These are the indicator LEDs. These are the indicators when you transmit and receive data via serial communications. Okay, now how are you going to code the Arduino? So basically, you have an open source Arduino IDE, which you can download. Like if you Google Arduino IDE, you can get the latest version. One, maybe this is not the latest version, you have to look for it. And you can also simulate Arduino system in TinkerCAD, which we will see later on. So how to do the coding? So basically, you can use Arduino IDE to do the coding, and basically once you have downloaded the install and extractor folder, then you can directly run the Arduino exe, and the IDE will look like the shown screenshot. This is how that system looks like, and here you will get the error message if there is something problem with your coding. Um, so before you code, you have to select the particular board, whatever board you have, and then you can connect, and then it will be detected through your USB, and then you can start doing the coding and download the code into the EEPROM of the Arduino system. And Arduino Uno can be programmed with Arduino software select. Okay, this one already have mentioned via COM3, that how you're going to connect it. So serial port communication. So you have to, the USB will be automatically converted into some virtual COM port and it will be connected accordingly. Okay, so this is how you do the connection. You connect this USB to this USB port and you can do the hardware connection, and then you can run the program with these actuators and with these sensors. So this is very major concept you have to understand. In basic programming, you need to have digital write, analog write, digital read, and then you have this analog read and if statement, serial communications. These are the very widely used uh, functions, or the uh, key function element that you will be using for Arduino programming. So what is a digital signal and what is an analog signal? This is digital signal, as you know, it is on-off signal. You have only between 0 to 5, so it is basically looks like a pulse. But analog signal can vary from 0 to 5 any value. So it has a triangular shape pulse, which varies from 0 to 5 also. This is analog signal. So analog sensors can be like photoresistor, potentiometer, temperature sensor, flex sensors, accelerometer, so on and so forth. So temperature measurement, your flex sensor can measure the bend and all these things. Digital sensors can be like light sensor, on off switches, push button, uh, light detecting like whether there's enough darkness or it is enough light is there or not. Not continuously measuring the by like photoresistor continuous level of light uh, intensity. Serial communications, sometimes we need to communicate the computer with the Arduino. So the most used communication method is serial communication, or you can also communicate from one Arduino board to another Arduino board. So that is also via serial communication. Serial communication is a standard communication protocol used by computer and the microcontroller board. So now we have studied Arduino microcontroller and also we have studied PLC. Now let's do a little bit of comparison. So in terms of primary use target, Arduino is used for prototyping, hobby projects, small automation. But for industrial grade automation, you need to go for PLCs. Arduino programming language is C, C++, Python, or some block-based programming technique. But PLC is more like ladder logic, structured textual programming method. Ease of use, of course, Arduino is even school kids they can use Arduino small projects, but PLC you need some specialized industrial knowledge. Reliability, Arduino is moderately reliable, but it is not meant for rugged environment, harsh environment for industries. It is not that rugged. It is not meant for harsh environment in industry. But in the case of PLC, it has to be very highly reliable and it should be able to withstand any harsh environment in the industry and should be operational 24 hours, 7 days a week. Sometimes the noise immunity is not that good for Arduino, but in PLC it is highly noise immune. IO handling, limited number of pins for Arduino. For PLC, you have hundreds, even thousands, and you can expand it very easily. The voltage level is 3.3 to 5 volt. In PLC, usually it is 12 or 24 volt. Communication, usually serial communication, SPI, Wi-Fi, Bluetooth, but industrial grade communication is available in PLC like Modbus, Profibus, Profinet, Etherpad, so on and so forth. Expandability, you can use Arduino shields and sensors. In PLC, you can expand it by racks and modules, as I have shown earlier for Allen Bradley PLC. Processing speed, much fast microcontroller, but it is slightly slower in PLC, but they are very highly reliable CPUs. Cost-wise, very cheap Arduino, but PLC usually will cost higher. And it is Arduino is open source IDE, but PLC is more like proprietary vendor-based software. However, there is a tendency nowadays going for open PLC, which is also, I think, Arduino based. But this is not so common still. Safety is built in for PLCs. They have when the company builds a PLC, they take care of all the safety features and applications. As I have mentioned, it is DIY, robotics, and IoT, factories, industrial plants. PLCs are used. Okay, let's try to do some coding. So basically, we want to do it's like a hello world type of programming for LED blinking. So we are going to use digital write. So you have to see first, there are two set of things that we have to focus: void setup and void loop for Arduino programming. Void setup is basically do this initialization of the digital pins, whether you want to make it as an output or input, so on and so forth. And then loop is going to do that. It's like a infinite loop. It will keep on looping as soon as the power is on. So basically, what happened here is, so what we do here is we assign this pin mode, it is a syntax, pin number 13 as an output. So we are assigning this as an output. And then we loop these things, we write this pin as high, means to say it should be 5 volt or 3.3 to 5 volt, and then we delay certain millisecond, 1000 millisecond means 1 second, and then we digital write, and then we make it low. So basically 5 volt to goes to down uh, 0 volt. So when this pin is connected to the LED, so the LED will start to glow and turn off, turn on, turn off every 1001 second. So it will turn on, turn off, turn on, turn off. So basically you are generating the pulses. So what you do once you have this thing connected through these tools, boards, and the board, then once you compile this, you use this button to compile this program, and if the compilation is correct, then you can upload it to the board, and then basically the program will be written or burned on the EEPROM. And if there is any error, you will see the error message coming here, a status message or error message. Okay, I think that's all. Now we will show you how it can be done in uh, TinkerCAD. So basically, as you can see here, you can see few things you need to remember. Digital write, pin mode, these are the key parameters we are going to use in the TinkerCAD as well. Void loop, delay, and so on and so forth. Let's see. So TinkerCAD is a website. If you go to TinkerCAD, so, and then you can log in through your Google account, so you will see this type of system. So you can start a code by using if you log in, so you can create new design. So you can get circuits, and then I have already a project here, two blinking LED. So let me show this project first, then I will show how to edit this thing. So they call it tinker this. So I put uh, click this one, tinker this. So this is basically the overall project. Now you can basically drag in these things like here, you can drag in, so on and so forth. And then you can delete this by just press delete. So similarly, you can have Arduino board. You can click in Arduino, Arduino Uno, let's say. So this is the Arduino Uno. You can drag another board like this, and then you can again delete. Sorry. Okay. Yeah. Okay. Now, once you do the connection, I will show you how to do the connection. I will edit this thing. So you can put it in the, you can put the code also here, what the code you want to run. You can see it is similar to exactly the same. You have the setup, void loop, all these things here. You can see this view. This is more like a realistic view. You can see the schematic. So if you see the schematic, basically what we are doing here is an LED is connected to a current limiting resistor to a pin, which is number, let me see, the pin number is, hold on, let me see the pin number. Here to the ground. So this is the connection going, so the positive connection is coming from, you can see 8, digital pin 8, and another LED is here, which is positive, is connecting from pin number 9. So the pin 8 and 9 are connected to the LED, and pin 6 and 7 are connected to the switches. They switch through the register, current limiting register also. So this is basically the system. So if you go back here, it is the same thing. So you have two switches connected via the register to the pins. So 6 and 7 and 8 and 9 are connected to the LEDs. Now, if you see the code here, so what we are declaring here is we say green LED number 8, integer red LED number 9, and button L number 7, button R left button, right button number 6. So all these digital pin, we have named it as some meaningful name, and then we put button L state and button R state as integer. I think this is, yeah. So it can be 1 or 0. So we put it as integer. Maybe you can try Boolean as well, because these will be Boolean values as well. And then we check void setup. So what we do, we put the pin mode and green LED as an output, red LED as an output, but button left as an input, button right as an input. So what we do in the loop, continuous looping, we first thing they do, the state of the button. So they digitally read what is the state of the button, L and right, left and right button. If the button is high and button R is low, so if it is high and this is low, then you blink for 500 and then red one, and then you go delay for, you select the delay value 500 and then you blink red LED, and then alternatively you blink the green LED. So high, low, and then you do the low, high, exactly same. And if it is other way around, R is high, L is low, then you do delay for 1000. And if both are low, then you don't make sure both LEDs are low. And if both are high, then you make sure that both LEDs are on. So this is basically the code. Now we can simulate these things. Let me try to make it a little bit more fun so that you can really see the difference. If we make it 50 and then we make it 1000, I think it will be faster so that you can see the difference. Let's say we start the simulation. Start the simulation. Now we say if I press this one and the other one we don't press. Press means high. So you can see it is around 50 millisecond LED blinking each of them. Okay. Now if I do this way, it would be 500 millisecond delay. Okay. Okay. Now let's say I want to edit these things. Okay. Let's say I want to edit these things. I want to bring in some LED here. Let's say another LED. So I can bring in another LED here, and then I can connect here. You can see it automatically detects the connection on the breadboard. So I put this as a yellow LED. Okay, yellow LED, and then I make this to be connected to the ground. So what I do here is basically I copy this one. Can I copy? Maybe not. Okay, let's see what I can get here. Wire. I think possible. Okay, let me see. Control Z. Here I have to select to black. Okay, so I have connected this cathode to the ground, and now anode should be red. So I connect this one to like this. Let me, and then I select this to be red, and then I think what I do is a little bit different. Delete it. I I drag it maybe from here. I drag it from here and then go all the way down. Okay. What I have to do, I have to get this register first. Control C and then Control P. Okay, I get this register. So I copy this. Now I can do the dragging. Okay, I go connect. Okay, so then connection. Okay, so I have connected another LED. So this is connected to 10. So I need to change the code. So what I do, I put here int yellow LED equals to 10 semicolon. So now I put here another one. Um, digital write. I copy this one. Digital write yellow LED. Yellow LED. Yellow LED to be okay. Let's do something else. Hi. HIGA. HIGA. Okay. And then delay. Control C. Control V. Delay the value. And then I copy this thing. Control C. And then I put here. You put this as low. Okay, we have to make another change. Add pin mode yellow LED as output. Okay, done. So now we try to start the simulation. Now we see what happens. Okay, there are some issues. Wire setup pin mode yellow LED. Oh, I did not give the semicolon. So let's see, we put here. Still there is a problem. What is the problem? Output yellow LED 10. No issue. What? Let me see. I understand. We've missed the W here. Again, another W here. Okay. Okay. Now we can click this. So the code will be gone. So we see now what will happen. So you can see yellow LED is also blinking. But if I press this, only green and red will be blinking. Okay. So this is how the system works. I hope you understood, and I will share this link with you so that you can carry on some editing and you can carry on this project further. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.